Yep.
Yes.
Okay. I'm talking about the imaging filters that I use. 3 filters for the one-shot color camera, the Optilon L Pro, the L Enhance, and L Extreme. And then we'll talk about the, I don't know if you call this beta or broad or some narrowband filters that I'm also using. So let's see if we can get, I gotta get my PowerPoint going. Okay. Slideshow from the beginning. Okay, now I think we're running. The first one, I started with this filter, and it's the Optolong L Pro. It's a general light pollution filter, and as you can see, it's passing a lot of light. The only carve-outs are whatever Optolong decided is light pollution. I think sodium vapor street lights is one of the frequencies, and some of the others. I'm not a technical guy, and so I don't worry about what nanometers or where it is, but it's just a general light pollution filter. It's the first one I started with, and here's of course good old M31. I would use the L Pro filter on all galaxies because it's passing all the colors through. It doesn't give you much protection from moonlight, but it's better. It's certainly better than not having any filter at all. But as I say, I'm going to use this on any galaxy out there because of the colors that you need to bring through. I'm also going to use the L Pro filter on anything that's a reflection nebula. Of course, we got the Pleiades here. In addition to star cluster, it's a reflection nebula. And in this case, the blue is not oxygen, but what we have is illuminated dust. That's these very bright blue stars that make up the star cluster are sending their blue light and making what would probably be brown dust, it illuminates as blue. So again, I'm going to use this on anything that's classified as a reflection nebula. Another reflection nebula, the Witch Head, again, whereas the Pleiades is very easy, you can grab it quickly because it's so bright. The Witch Head's kind of at the other end of the spectrum. It's very dim. As you can see, it's in a dense star field, and it's difficult to bring out all of the illuminated dust here. But as you can see, this image was taken, most of mine are with the C11 and Hyperstar. This one was with the wide field of the Red Cat 51, and where I'm using 5-minute exposures and quite a few of them. So several hours of accumulation here. But if I'm going to get a reflection nebula, particularly a dim one, I'm going to use the L Pro filter, and I need to have a dark night. It's not going to work well if you have much moon involved. So that's the L Pro. Have any questions or discussions? I've not tried any other filters, but other brands of filters. So go ahead. Yes.
Where were these taken from? Were these taken from like what location?
Everything you're going to see. I don't ever travel.
Okay.
I shoot from my backyard. I'm in Saddlebrook, probably 25 miles north of the center of downtown Tucson. And I'm only about 3 miles from where highway 60 or 79 and 77 converge. I can be up in Oracle in about 15 minutes. So if that gives you any indication.
Yeah.
I have a restricted view that's pretty much east and a little bit south and a little bit of southwest. Fortunately, I'm shooting towards the Catalina Mountains in the east. So I try to catch things as they're going up or not very far over the meridian. So that's where they're from, but all from my backyard.
Okay.
So any other questions or comments on L Pro or other filters that people have found really effective for just general light pollution?
I have one. What was your telescope for this? For those
Say again, please.
What telescope were you using for those sample shots?
C11. They're C11 with the hyperstar. So I'm getting 540 millimeter focal length at f2, or it may be f9. So anyway, it's fast. And that's what I'm generally shooting. I'm on an EQ6 Pro mount, and I have everything on a scope buggy. I drag it out to I have a couple of holes drilled in the cement, and I just lock it down to the same position. And I'm using the ASI Air, and I use all of the routines from polar alignment all the way through the guiding and everything that it does. So
with the L Pro filter and at f2, when you shot an image that had a really bright star in it, like perhaps Rigel, did you notice much by way of halo around that star?
you will get some halo. If we, of course, these are very bright stars here if we look at it, but let's go back again to the Pleiades. You're going to get some halo with them. This was 2-minute exposures, which is fairly long at f2.
Didn't you get a dark one?
I'm using, yes, I am using darks, and I am using flats to process these. These are all the ZWO 2600 camera. It has a very deep well, and you can shoot a long exposure and not blow things out too badly. So, okay, let's talk about the second filter that I acquired. That's the Optilon L Enhance. Very different from the L Pro, because we're going after just hydrogen alpha, oxygen 3, and hydrogen beta. So it's very restrictive. We're just going after three bands here. I would typically use this on anything that has basically red. If hydrogen alpha is a key component, I would use this. This one I did take with a wide field of Red Cat 51. And again, 5-minute exposures here. It's shooting at f4.9. You're capturing a lot of color here. You're getting all the nice brown dust. What you are not going to get with this filter is which the Running Man is really a reflection nebula. You're not going to get the blue there, or if you do, it'll be very little of them. So you're going to miss that, but all of the other colors are good. I will say the L Enhance makes pretty nice tight stars. It can make them have a green cast. And if you are taking the stars, if you're removing the stars with something like StarNet, and it's not hard to fix and to get rid of the green cast. But if you just shoot, you are going to see some green show up there. It's not bad on these extremely bright stars. I mean, they could be a lot more blown out than they are. I'll show you an example. Here's with the L Pro. again, and this would be the C11, but you can see the blue dust or the blue illuminator dust that you're not getting when you're using the L Enhance filter. This is another example of M17 with the L Enhance filter. And this was before I was probably processing and removing the stars. You can see a little bit of green cast in these stars. It's almost a blue-green. But again, it's a nice filter for anything that's primarily hydrogen alpha, and you bring through a lot of light, and it's fairly effective. You can shoot this with some moon if you're shooting away from the moon. It's not bad at all. So any questions on L Enhance filter or any comments on that? Okay. The third filter I use with the one-shot color is the L Extreme. This is a 2-band filter. It's hydrogen alpha and oxygen 3 only. And even the hydrogen alpha is narrower than the band that you would get with the L Enhance. This is the more recent one of the from Optolong. It's very good for bringing through O3. But what I have found, and it also delivers nice tight stars. It is very moon tolerant. You can shoot this with quite a bit of moon showing. It brings through lots of O3, but what I've noticed is it does not bring through as much hydrogen alpha or red as the L Enhance. So my solution to this has been use both. I just stop my imaging run halfway through it, and I slide one of filters out and put the other one in, and then just continue and process them all as if they were just all one continuous file. And I'm able to get the best of both, because I don't have just an example where this is just one or the other. But I can tell you that by combining those two filters, I'm getting more of the red and plenty of the O3 teal. Again, this is another example here of M27 where I have combined the filters. And again, just shooting half of my imaging time in one and then switching the filters and going to the other. And I'm definitely getting more of each by doing this way. So, and you still get plenty of nice star color when you do it, when you're using these filters. I'll show you this one here. I was testing the Explorer Scientific 127. I was looking for a scope that had a larger image size. And when you shoot this in native focal length, it's 952 millimeters compared to 540 that I was getting with the C11 Hyperstar. But you're going from f2 to f7.5, so it's quite a big difference there in how the speed of it. And I shot here 5-minute frames. What I wanted to show you here was this was shot with probably a 95% moon for the entire time I was imaging. So the L Extreme filter is quite moon tolerant. And given the moon was, coming up in the northeast, and I was shooting to the south, and it just recently, you can see this is just a week ago or so. But this filter will really extend your shooting time as far as nights that you are using. And I noticed the couple of images that Wanda posted, I think it was this morning, that she had shot with the L Extreme filter really came out nice as well. Nice, tight small stars, and plenty of color. So anyway, it's a nice filter to use. If I were to choose whether I only had the L Extreme or the L Enhance, I might go with the L Enhance just because it does let a little more light through, and you're going to capture a little bit more of the reds with it. And you know, the west veil is kind of, you don't see a lot of objects that have as much oxygen-3 in them as it does. So, but if you're going to shoot the west veil or the veil at all, the Extreme and the L Enhance combined work quite well. Any questions, comments on the Extreme?
Randy, it's Jeff. Have you differentiated exposure times among these different filters based on their relative band passes or light throughput?
I have not. I've kind of, to me, because of the tolerance of the 2600 camera, I tend to shoot as long as I can get away with and still get good guiding. So I don't know if that's the right thing to do or not, but that's what I've done. Probably it would be unusual for me to shoot less than 2 minutes on anything, and a lot of times I do 3. Now, that being said, that'll bring to the next thing. I have also picked up a 2600 monochrome camera, and this is a whole different world. I just wanted to see what this is all about and see what is there. Initially, I picked up this, how do you say this, Bader or Botter? Any authoritative pronunciation?
I work for a company whose second language is German. It's Botter.
Botter, okay. I'll go with Botter. That works for me. When I bought the mono camera, I also picked up the Botter filter set. This is only hydrogen alpha, sulfur 2, and oxygen 3, and they're very narrow band. 3.5, I think, is oxygen, and the other two are 4 nanometers. So they're very narrow, and this is what I've worked with for some time. These filters are restricted to, they advertise them as F2. You might be able to go a little bit slower, but that's what they do with them. That's what they're supposed to be for. Here's an example of course, the monkey head, that's an HOO. What this means is I'm only using hydrogen alpha and the oxygen 3. Even though I had the sulfur 2 frames, I didn't use them for this. And the idea is you can get something that's approximates traditional color. But what I'm doing, what you do here is you map the hydrogen alpha to red, and you map the oxygen 3 to both the green and the blue channel. And so here's something what you get, something that you get. You get very nice tight small stars. It's the hydrogen alpha is almost moonlight proof. It's, again, when you're doing 4 nanometers, just at hydrogen alpha, nothing else is getting through. These filters, when you look through them, they look very thick. And I'm shooting 3 minutes here, again, with the C11 Hyperstar. But you do get some nice detail that comes through. Now you can, this is the same file, but all I've done here is process them differently. I've used the hydrogen alpha and the sulfur 2 and the oxygen 3. But to get the Hubble palette, you're mapping the hydrogen alpha to the green channel. You're mapping the sulfur 2 to the red channel and the oxygen 3 to the blue channel. And so that you're going to get the Hubble palette when you do that. So it's two ways that you can use the Botter filters there. And I know they make some that, and Optolong makes them as well, that are not restricted to the f2 speed. But anyway, something interesting to do. Of course, you can take the one-shot color and you can process that and get Hubble palette out of that if you want to as well. So that's what I've done so far with the narrowband and the Botter filter set. So any question on those filters there, unless you're shooting something with Hyperstar or RASA, I don't think they're going to work for you. So, and they were very expensive, I'll say that as well. So
I'd like to go back a
They're
little.
also not available anywhere right now. I've
Well-
been trying to get the HA and everybody is sold out.
let me go ahead and say this. There are some identified problems, particularly with the O3.
Yeah.
And if you if you see any of the Lazy Geek YouTube videos, he has panned this filter group because of the O3. And what he said, and from what I've understood, it's accurate, that the O3 filter is not made correctly. What I've noticed when I shoot the HA and the S2, they're very low noise and lots of signal. But when I shoot the O3, I get little signal and lots of noise. And that's very likely, once the seed of doubt is planted, it doesn't take much to make it grow. I do understand that Botter has owned up to the problem, but so far they haven't offered a fix. I'm hoping they would get a replacement filter for the O3, just so if it could be as noise-free as these other two, it would really be a joy to shoot. So that being said, go ahead, Alan, if you had some comments, or Alex.
Yeah, I just wanted to point out, you said that on one of the filters, you got more red than you did on the one with a narrower band pass for the hydrogen.
Yes.
And I suspect the reason for that is the wider the filter, the hydrogen signal will be the same, going to be the same going through both of them and being recorded. So it's only the background red, the continuum red, that changes between those two. So what you're really picking up, I suspect, is more continuum red, which isn't part of the hydrogen signal at all.
Okay. Does the hydrogen beta enter into it that the enhanced filter has and the extreme does not?
Not in terms of the red part. I mean, the thing about it is all of these lines sit on some background shape, which is the base. That even if it weren't emitting, it'd be some red, some blue, etc. And so there are ways to subtract out that continuum amount, but you have to shoot RGB as well as narrow band, and then do a little mathematics on them. But I suspect that's what you're seeing, and the blue is going to do the same thing. If you have a wider band pass in the blue, you're going to pick up more of the continuum, and it's going to look bluer. And then, of course, all that changes once you've done image processing. You can make it redder or make it bluer. The net is down at that point.
Alan, did you have something to add?
I was just going to say, if back on the L extreme, just as an FYI, I use a RASA 8 with an ASI 294 one-shot color. And with the L Extreme, I got very excellent results with my images, with the exception of really bright stars. You get around Mag 5 and the halos were just way too much. I tested a couple nights ago a filter by IDIS, which is called an NBZ, which Woodland Hills had recommended to me. And it was a great improvement. There was still a little bit of halo with the stars, but it was a vast improvement over the L Extreme.
Okay, thank you. Anything else? I have just started. I picked up a set of just Optilon Lrgb filters, and I've only used them one time. So I'm just starting to get into that, but I can tell they're not going to be moonlight tolerant at all. They pass almost 100% of light, and you can just tell by looking at them, they're not going to filter out much of anything. So that's where I'm going next as Galaxy season comes up, hoping to get the little finer detail of the narrow band and to go from there. So that's all I have to say. Any other questions or comments? Otherwise, I will unshare my screen.
Hey, Randy, this is Kevin. Quick question.
Yes.
When you're doing the one-shot color with those Optolong filters, do you do anything different when you do your color calibration? Do you still manage to do a successful like photometric one in PixInsight?
I'll have to admit, I do the easiest one. I either do auto color in the easy, in the auto color utility, or sometimes I just do the plain old color calibration in PixInsight. I've had as good a luck with that as anything else. I'm not a technical guy. I go for what's the easiest and seems to produce something that works for me.
Yeah, I sort of struggled with the photometric because either the object would look funky or the stars would look funky. And so maybe you have the right idea as the target's more important than the stars. They're the background.
Yeah, I'm into simple.
Yeah, I am too. Thank you.
You're welcome. Okay, Greg, it's back to you.
All right, well, thank you. That was a great presentation. I think you've got some really good images to prove the fact that you've got that the Optolong's mastered, I think. So thank you for doing that.
You're welcome.
I think Doug, are you available?
Yeah, I'm here.
Okay.
Can you hear me? Okay, good.
Yeah. Good.
So I'll go ahead and share my screen.
Do it.
Okay, can you guys see my my screen?
Yep, got it.
Okay, so maybe a first word about this data management talk, and that is that the title looked more generic than it's intended to be. This is data management according to Doug Summers, okay, and his example of data management, not necessarily what everybody else needs to do. So with that caveat, I will share what I do for data management, and then you can decide whether or not any of this makes any sense to you. So a few slides to start. Maybe the first question is, why bother? And is it worth it? And I think, for me, some amount of data management is worth it because I need some way to organize and manage these files. So in my case, I'm sitting on right now about 28,000 sub-exposures with the calibration files. And I've got another 1,000 files or so for my intermediate post-processing products. That's the final images and the files that I save that I can't easily reproduce. And just FYI, I don't save anything that that can be easily reproduced. So I throw all the intermediates away, except for things that take a long time to produce. I use some data management to help support the future capture sessions. Things like the next sequence number. If I'm going to take data tonight and I'm going to take data tomorrow, I want to know what number of the file I need, and having an archive of some kind helps me to know that. Sometimes I'll use it for helping with framing in case I wasn't on the target proper, but I'm in the middle between two stars or something. I might want to know where I was there. And then, of course, exposure settings I might want to know as well. On the metrics side, I'm really using Archive to help me with metrics. And that is, I want to know a little bit about the sites that I'm using, my house, CAC, or anywhere else I would go, and the gear. How is the gear performing? And I want to watch that and see how things are progressing. And then I keep my observing history and my logs, both for guiding and for focus. And I think I've been able to really make a big difference in my observing as a result, particularly of focus. So, okay, maybe for a moment, I'll just tell you how I capture, might help to understand the flow. What I do is all of my images are saved on the OTA. I've got a little SSD up there with a Raspberry Pi 4, and they're saved on that SSD at night. And then in the morning, I'll transfer those files off to a laptop hard disk so that I can take a look at them. The next thing I'll do is take a quick look with metrics. I'll blink them and use CCD Inspector, and then I will throw out all the bad subs. This helps me if I need to change my observing plan for the next night. I can have a chance to do that before I just, I don't want to have a terrible night, have to throw everything away, and then move on to another object and realize that I didn't get what I needed. So I can change my observing plan if I need to. The remaining files, the ones that I haven't thrown away, I transfer to a work in progress area on the archive hard drive. And those just sit there, and then I'll merge. If I know that I'm taking data that I've already taken either months ago or last night, I will merge those files together into a work in progress area so that they're all together. And when they're together, they can sit there for as long as they want. They're just sitting in a work in progress named image area on the hard drive. And when I'm ready, I can go back, I can look for that area and then post-process. Okay, on the post-processing side, that work in progress area that I just mentioned, when I'm ready to post-process, I'll go into that area, I'll look for a particular image with all its subs, and I'll transfer that whole set into the PixInsight work area on my processing laptop. I then use PixInsight subframe selector to take a look at the entire set of data as a whole and evaluate them, weight them, and then approve what I want for that image. And I'll abandon all the other subs. I use CCD Inspector, but I want to make a note that you can easily use selectors CVS file structure for that, right? It's just an output file. And I use that for a metrics report that I put into an archive summary, which includes some subframe statistics, and I'll show those. Once I've got that report run, I will just cut and paste that into the archive so that it's a permanent record that I've got copied that I can look at it offline. And then I'll go ahead and do the post-processing in PixInsight. And when I'm done with that post-processing, I take all the remaining raw files and the particular products I want that were intermediates that were harder to reproduce, and I'll push them back to the archive hard drive. Everything else goes in the trash. I don't save all the intermediates because unless it's really hard to reproduce, I just throw them out. Okay, so here's a quick look at this CCD Inspector. Some people ask me, well, how do you know the full width half max on your images and what have you? And this is how I generate that data. So I'll just open the files up. There'll be a big long list. I'll push the measure all button, and one by one, they all start popping in with their full width half max, the background, the eccentricity. I keep air mass and altitude as well. These are taken way back in 2020. And so since then, I've added the air mass and altitude. But generally speaking, once I get this report, I can cut and paste it straight into an archive form. Okay, so I mentioned before that you can do this in CVS with subframe selector, and you can tell that this is a report coming out of a subframe selector, and it's obviously a lot more ugly. It's not quite in the right format, but if you can imagine just taking these rows, deleting them, and then taking some of these columns and deleting them, what you're left with is file, weight, here's eccentricity, full width half max, altitude, and azimuth. So you can grab what you want. And what I've done is I just quickly went through and reformatted, cut some rows, cut some columns, and reformatted the numbers so that you could see a report that is essentially the same information that I'm doing with CCD Inspector. And so you can cut and paste this and put it in the archive just as easily. Okay, so I'm going to show a copy right after I get done with these spreadsheets or with these slides of my archive. But this is basically what you've got. I've got one line, which is a summary line of all of the roll-up of each of the frames for that object. And so I've expanded. What happens is I just hide. This is an Excel spreadsheet. I just hide the lines that are the subframes. And you can tell down here, like with a horse head and the snake and what have you, these are all the summary lines. Normally, all these lines are collapsed, but if I want to uncollapse them and take a look at them, do some sorting for particular things, I could do that. But in general, that's what I get. A summary line with some summary statistics, and then the individual lines where I've copied the the statistics from either CCD Inspector or subframe selector into them. Okay, so now for the metrics. So this is what I like. I'm kind of a data, fan, and so I enjoy this part of the problem. But if you like metrics, the Excel spreadsheet's the way to go for that, because you can just generate the graphs straight off of the summary lines. So this is a snapshot of some of the archive metrics that I keep. So on the top, for instance, I've got for over 20,000 subframes. You can see how elevation angle, for instance, on the left-hand side correlates to full width half max. And as it makes total sense, you would expect that as you drop down to 10 degrees elevation, you're not gonna be able to get 2 arcsecond images, right? You're gonna get something like 4.5 at the best, and it could go all the way out and be worse. Now, these are the saved ones. These are not the ones that I threw away. These are the ones I kept in my archive. So that gives you kind of a hint of, what full width half max is looking like. Here's another one, a histogram that I generated that basically shows most all of my work is between 2.75 and 3.5 full width half max on all the subs, with some tail, right? My elevation spread, those are exposure level graphs. For images at the rolled up level, I've got some other graphs. These are the images that I took at CAC. And so you can tell that at CAC, I drop down a little lower, right, than I do when I'm at home. And I take more images at CAC than I do at home. But in general, I'm in the 2.5 to 3.5 regime for a lot of my images. And when I go low, I have to accept something more than that. My elevation distributions all over the map, which you'd expect. And then kind of interesting, I'm characterizing how does my backyard compare to CAC? And I am in a pretty dark area in southern Colorado. But you can see that my sweet spot, I take more images, by the way. I got 3,000 subs out there at CAC as compared to only 800 subs, for this particular regime here. But you can tell that I'm in the 650 regime for the majority of my frames at CAC. This is when I'm at home plus CAC, okay, and the pattern looks similar, all right, as to this pattern, even though the frames are different. But when I get to my house, it's a little different. So I'm going to say that maybe somewhere between this 675 to 700 and this 775 to 800, maybe right in here is the sort of the midpoint at 725 counts of background. And at CAC, I'm getting 650 counts. So I definitely have, 10 to 15% more counts in my backyard for the background than I do at CAC. And that makes sense. CAC is a really dark site. I'm not unhappy with my backyard, but this gives you sort of a character of that. Okay, I mentioned before that I keep all my guiding and my focus metrics. And so all my logs I keep they're not very big, and so it doesn't hurt to keep them. And it's a good idea to go back if you ever have to go back and take a look at how things were going. You can look at them there. So I've shown a guide frequency analysis, and then I've characterized about 1,000 focus V-curve runs on my focuser, and so I know very well how my optics behave in the presence of temperature changes and what that means in terms of what I need to do to run my focuser. The spread may be big, but the actual function itself, I will do one V-curve, and then I will sit and I will drive down that function for the V-curve that I solved, and then I don't have to run focus V-curves. And when I'm at F2, and so when you're that fast, especially at the beginning of the night, you need to do a lot of focus curves, but I don't have to do that because I know my focus well, and I can do one V-curve and then watch the temperature fall, and I'm automatically changing focus between the exposures. So very helpful to have done that. Okay, so I wanted to mention a couple other things. I do keep my observing history in another spreadsheet. That's a planning spreadsheet, and I just keep it up at night with me. And so it makes sense that when I'm there, I just cut and paste these things over into my history. So when I'm done at night, I can tell what I got. Green is good and red is bad, and yellow is marginal. And so from that perspective, I can cut and paste over a series. And you can see these are months I've got over here. I keep the location of whether I was at home or at CAC, and the times and what my plan was and what I got done. So I keep that in a spreadsheet as well. I moved my final images to a best folders on multiple laptops. I do push a bunch of my images to cloud storage up on Astrobin. And Astrobin, by the way, keeps some additional metrics that I like. So views and likes, etc. And here's something I played with this afternoon that I thought was a little bit interesting. I just took a quick capture, and I said, all right, well, I was looking at views. So views compared to the amount of seconds of exposure. And you'd think that there should be some correlation there. And of course, there is a little bit of a correlation, but there's also some questions that can get asked, like, why is it that I've got almost 275 views of an object that only has 100 minutes of exposure there, right? And why is it that I've got some other ones, okay, like this one over here, that's only got 50 views, but I've got 280 minutes of exposure? What's the rationale for that? Can you make any sense out of that? Sometimes these graphs raise more questions than answers, but they're fun to look at. This is the same thing with likes. I was able to plot the likes and see, well, that's a little sloppier, but in general, there is a little bit of a correlation. If you take more data, probably you're going to get more people to look at your picture. So that's the moral of that story. Okay, so what I want to do now is I want to maybe take a quick peek at the archive. So this is the actual archive. And what I've done, I think I can undo the row height. Yeah, so for instance, I just expanded the Horsehead Nebula, and you can see the individual frames. And if I wanted to do, something in here that was interesting, either maybe I want to know what the next sequence number I want to shoot is. So I could sort on that H column, and I could find out what the next sequence number is, or I could sort on the eccentricity, which CCD Inspector calls aspect percent, or full width half max. And so just for fun, we'll go through and say, well, what if we do that? Let's take a look. And if I sorted on J as an example, smallest to largest, I could go down and I could say, well, okay, if I know, for instance, that eccentricities above about 25% are not great, maybe the next time I want to go out and shoot some Horsehead Nebula, I might want to replace all these frames down here, get rid of them, and try and grab some better frames and shoot a better Horsehead. This is why I think the archive is powerful, because I have all of my frames, all 20,000 are sitting here, and I can go back. Now I can, let's say if I take this off and I undo the height measurement. Whoops, let me go back. What have I just done? I will just collapse these, hide them again. Oh, I see what I've done. I've just messed myself up here because I was doing something before. I can just grab these and I can hide them manually. Okay, and now I've got basically, if you go down, you can see all the gaps in here, right? You can tell where all these subframes are. And so if I go down to the bottom, I'm sitting at a little over 20,000, almost 21,000 frames here. And I can basically pull up whatever I want, whenever I want to. And then if I'm going out to shoot another object, remember in the beginning, I was taking surveys. So I was just doing half hour on particular objects. And if I want to go back later and take 3 hours on an object, I need to know where to start from. And I also need to know what was the length of the exposure times that I was using and what was the temperature, so that I could make all the calibrations come out right. And so this is a good way to solve that problem. So the last thing I think I want to show, here. I wanted to just mention that something that I've been bugging Astrobin for a while now, and Salvatore finally did it. I noticed that he ignored me for about a year, and then he said, I think this is a good idea. I'll do that eventually. I wanted him to make these tabs in the, you can look at picture view, which is the normal way Astrobin, the thumbnail images. But if you go to table view, you can see everything sorted, and I wanted to be able to sort on these tabs here, and he couldn't do it, but he has actually put them in now. So for instance, you can go in and you can do sorts on your views and your likes or the names and what have you. He keeps some statistics for that, and I used to just copy those statistics into a spreadsheet and then sort them so I could see how that all worked. But now he's got some of that actually built in, and I think that's pretty good. So I think what I'd like to do is maybe leave it there and ask whether or not anybody has any questions. Certainly not as sexy as looking at pictures of space, but if you've got a lot of frames, sooner or later you're going to figure out you need to manage them somehow. And I think you could go complicated with a database, or you can go simple with a spreadsheet. So I'll leave it there and let people ask questions if they have any.
Doug, talk a little bit about the physical side of data management. Where do you store this stuff?
Yeah, okay, so let me unshare my screen. Okay, here we go. That's it. Sorry, so I think I didn't get to all of my screens, but I thought I did. Maybe I didn't get the last bullet. I've got 2 of these little disks there. I got one that's 4 terabytes. This one's 5 terabytes. I keep 2 disks, by the way, very important. I copy everything over. So my entire archive, everything I've got and everything that I've saved is 1.5 terabytes. So times 2, because I have 2 copies of it, is 3 terabytes spread on 2 drives. And that's not too bad. And if you, what I do on the other physical side, let's see, I guess I can share I've got a pretty flat directory structure. So on the archive itself, I just have an images directory, and inside that images directory is 1 directory per image. And then all my stored files, my raw, my FITS files are there. And I do keep, I mentioned the intermediate products that I keep. I do keep the integration image and the drizzle image. Why? Because that takes a long time to calibrate, and you've done a lot of work to get ready. So once you get the integration image, I just save that image. And if I ever want to go back and reprocess, at least I can start from an integration image. I also keep the last linear step that I do. Because again, I did a lot of processing on that. And so I don't want to have to go back and redo the deconvolution and what have you. And I will also keep the first nonlinear image, so that if I do want to go back and let's say, sometimes you process these nonlinears, and I mentioned this before in one of the talks, but I find it very difficult to reproduce. I can go back and I can recrank my linear image anytime I want, and it'll come out the same every single time because it's kind of a mechanical process. But on the nonlinear side, I can almost never reproduce what I did before on the nonlinear side. And so that's why you keep that first image going into nonlinear. I save that image, because if I overprocess, if I screw up, if I do a mass stretch and then try and unstretch it, it'll be screwed up. And that first linear image or nonlinear image going right out of mass stretch, I'll save that image so that if I ever want to post-process again, I can do that. So I don't know if I answered your question, but that's my answer.
Thanks.
All right. Anything else on archives?
Yeah, Doug.
All right, so yeah,
Hey,
go
Doug,
ahead.
it's
Alan.
Alan. Could you just
Yeah.
talk a little bit about your file naming convention? It looks like you keep it pretty simple.
Yeah, I do. And I was going to share my screen. Maybe I'll share my screen one more time just for a second. Okay, and I'll get rid of this and I'll bring up my disk drive so you can see it. Can you guys see this? Can you see my
Yes.
my screen now? Okay, so here I am. I'm sitting in images. All right, and I just make a file for each of this is one each of all the images that I've captured that I've been working on. I mentioned before this work in progress area, right? So for instance, if you want to know what I'm working on right now that I haven't processed yet, well, I've got some M15, 4156 and some cat's eye data, yeah? And it's all sitting in there. I can just pull it over when I want and process it. I do keep some, when I transfer from my Raspberry Pi, I have a Pi directory that I transfer everything into. Until I have a chance to push it over into work in progress. But for instance, so here's 5128, and you can see basically what I've got. I've got one big flat directory structure with all my frames in it. And then at the end, right, I've got a linear frame that I kept, that I processed. And at the top, I've got my drizzle integration. That takes forever, so I don't want to reproduce that. My original integration file and the final product, right? The full and the crop. That's typically what I do. Flat file structure, just the raws, the integrations, the final crop, and the original full frame in case I want to look at that full frame again in the future. And then the drizzle products. Yeah. Does that make sense? Did I answer your question, Alan?
Yeah, so do you just have working directories? I think the other day you said you have 4, right?
Oh yeah, on my PixInsight, on my laptop, I keep 4 generic work areas that I can push so that in case I have different calibrations. In the beginning, I was taking data at -5 for 30 seconds. And now most of my data is either, it's almost all -15 C, but 30-second or 45-second integrations. And as a result, when I need to calibrate, I have to push the raws into one of those generic directories. And I keep those directories separated while I do the calibrations. And then I'll use one giant folder for the final processing.
So you don't build any of the temperatures or anything like that into the file names?
No, I do not. Yeah, because again, all of that data is kept in my archive. And so if I look down my archive, I can see that, for instance, if I'm doing, let's say I want to do some 6823 data, I'll hide that and I'll see that, oh, okay, where am I staring here? Interesting. This is data that I took a long time ago, I guess, because I don't have my CCD temperatures here. But generally, I've got all the CCD temperatures in my archive report, and so I just go and look at both my exposure durations and my CCD temperatures from that listing. Sorry, let me try one more. Let's see if I can look at some data that's a little newer. I'll take a look at maybe, I'm pretty sure this guy has the right stuff in it. Let's unhide that. Yeah, there you go. So it's all in there, right? -5 and 30 is what I'm taking here. So if I'm taking more data, it's almost inevitable. I'm going to take -15 and 30. I will need to separate the 5s into my work 1, and I'll separate the -15s into the work 2. I'll calibrate those separately, and then I'll merge them together for processing, right, during integration. Does that make sense?
Yeah, and how do you decide, or do you decide to use the common name, or do you say M42, or do you say Orion Nebula in your file name, or both?
That is a function of the search that I do in my the software that I'm using. When I type in M42, let's say, it comes up with a M42, or if it was some other object, if I didn't know the number, or I was careless with the number and I said, give me the Orion Nebula, it probably would find it and still use M42. And so some of that naming convention gets confusing. And you'll notice in the original example I used, I had 2 different names for Horsehead. Sometimes I looked and I searched by Horsehead and it gave me that. And at other times it gave me, a different name. And so I'm not always very careful when I do that, and I don't need to be careful. But what I do have to be careful about is once I do have a name, if it comes up the same, I need to make sure that that sequence number is correct. So if I've already got 150 frames or 100 frames of one name, and I'm going to take more data of that, I need to make sure that my next frame is numbered 101, as opposed to starting over from 0. Otherwise, I'm going to have a problem with naming conventions. Yeah.
Mhm.
Do you keep header files that in your FITS headers, information about temperature and date and information like that? Because a lot of that data is used in PixInsight, like in WPBB.
Right.
It searches for that header information and automatically sorts it.
Yeah, I do. And in fact, that's where this data comes from, right? I didn't put any of this information in. It extracted it from the header. CCD inspector extracts it and subframe selector extracts it. And so all of that is all taken straight out of the header. And I add a couple more fields in there, for myself, right? The weighting information is in there and my observer name is in there. I think that's probably the only two that I'm adding to the, to the header.
Also, do you save your PixInsight projects? Because there's a lot of information on the processing accumulated within that project. So I just save the project, and rather than individual frames at various points.
Yeah, I don't do that. I'm aware of it, and it's a conscious decision not to do that in my case, because again, I started doing surveys with small amounts of data. I'm constantly adding to that data. Maybe in the future, if I had taken a one-time, I'm going to do 6 hours, I know I'm doing 6 hours from the very beginning, I might create a project. But since I know I'm going back over and over, throwing out bad frames, adding new frames, and reprocessing, the overhead of keeping the project seemed a little bit heavy to me as compared to just keeping the subs and then reprocessing. That's a personal choice. Okay, if that's it, I'll turn it back over to Greg.
All right, thanks, Doug. That was very, very enlightening. I think
Yeah.
the last thing we're going to do this evening, Kevin had a couple of images you wanted to share with us.
Yeah, I do.
Kevin
Okay.
Cook had a
Whichever
couple of
order
images
you
to
want,
share.
Greg.
I'm sorry.
Whichever order you want.
You asked to share, so go ahead.
Okay, this will be the antithesis of Doug's quantitative analytical presentation. This is continuing in my master class on how not to do astrophotography. So let me share the screen. This was supposed to be wide field of some of our winter constellations before they disappear. So you've got Orion, you got Auriga, you've got the Pleiades, and you got these strange colored clouds. And it gets more interesting. And there will be a lesson at the end of this of what I did wrong. From this point, it got significantly brighter very quickly. These are from Iceland from a week ago. I just got back at 3 a.m. yesterday. So these are minimally processed, but I tried to sort of standardize the exposure level. And you can tell the aurora has brightened, easily by a factor of more than 2, just in the span of a few minutes. When it gets that bright, it also becomes very fast moving. And one of the mistakes I think I made, these were 5-second exposures. Had I been paying attention, I was paying attention to the histogram to make sure I wasn't blowing out the green channel. But had I paid attention to where the peak was falling, I probably would have dropped the 5-second exposure down to 1 or 2 seconds. It was that bright. And literally the ones I'm flying through are about over the span of 4 minutes, this much motion. And so the lessons I learned from doing this, if I did it again, number one, I would not try to do 2 camera systems. That requires unmounting them from the tripod, rechecking your focus and all that. The other one I was doing was an Olympus full frame fisheye, which didn't really work because of where the moon was sitting. You know, it would encompass the full range, the arc of the aurora, but the moon, you know, at the waxing past the first quarter was kind of dominating the peak of that arc and washing out sort of the central part of the image. So these with a 20 millimeter on a full frame turned out to be much better. Second, if I had to do it over again, I'd say do a wide angle zoom as opposed to fixed focal length lenses. It gives you more framing options without having to change anything that's mounted on the tripod. And the last obvious lesson is as it gets bright and fast moving, pay attention to your exposure when you're in manual mode. Because again, in hindsight, I could have cut that exposure down to 2 seconds or even 1 second, still not lost quality and probably had a little more sharpness in the aurora images. That's it.
Kevin, those are
next.
fabulous.
Oh, the other lesson. This was Iceland claims that right around the fall and spring equinox is the best time for aurora photography. And what I have concluded from that is they're not going on number of dark hours, they're going on weather patterns. And while you'll have more darkness in December or January, you have crappier weather. Out of 7 nights there, we had 1 clear night. Now, fortunately, that coincided with one with a fair amount of aurora activity, but that's not great odds. That's
Kevin,
it.
I'd be ecstatic to have those pictures. Those are awesome pictures,
I
buddy.
am, but you know, the perfectionist in all of us says, yeah, how would I do it better next time?
Yeah, those are really nice.
I'll unshare here. How do I do that? Stop share.
Okay, thanks for that, Kevin. That was great.
I've got a couple of images to show also.
Okay, we're just about out of time, but go ahead.
I finally got my first images with my 2600 on my, let's see, I'm going to go to share screen. Okay. Okay, you see it? What is it?
It's you, Paul. We don't see the.
Yeah, we
I
don't
don't
see
see
that.
anything.
Oh, you don't see it? Okay, I hit share screen. Okay, let's go back. Oh, I have to hit the share button. All right. Now let's.
There we go.
Okay, what is it?
It's M81.
Yep. Okay, this is my final, more or less my final image taken with using PixInsight. I had to get a lot of help with that. This was taken with my 6-inch refractor and that same camera that Randy used, the 2600, but this is the single shot color. Anyway, check out the detail on this. Also, there's a small irregular galaxy here, which I believe is a Holmberg object. And it's, I'm not sure if it's even if you can see it visually. I mean, we may be able to with the 40-inch out at CAC. But anyway, this was taken with my 6-inch refractor. Check out the detail here. Also, look at this, these plumes were just starting to show along here. All of this, I never realized was there. I was able to capture all the inner detail. This shot actually goes deeper than a shot that was, than a photo that's in the Hubble Atlas of Galaxies. It was taken with the Palomar 200-inch. Although that image does blow this one away as far as resolution is concerned. Well, trying to compare a 6-inch to what a 200-inch can do is probably absurd to begin with, but I'm kind of in the ballpark with that image, but just not on the pitcher's mound. He got some, on that image, it got some resolution, surprisingly enough, even at the distance of this galaxy. But you can start to see some of the, there are quite a few individual structures here that are showing up, and this outer halo. And here is something that I've never seen. Look at this. There's like a detached spiral arm here, way out here. And I don't know if that's possibly an extension, that this arm comes all the way around, but I'm planning to take and go a little deeper and take a few more subs and eventually combine them. Now, here's M82. This is it blown up 60 times, by the way, from the original image size on the sensor, the way it appears. Look at these outer filaments here that I got. Look at you can really see the explosion taking place in the middle. And the images are still, they're just starting to lose their sharpness, the star images here. But anyway, I was able to coax out the detail and realize that a 6-inch aperture could produce anything close to this. And even 10 years ago, this picture would have been unheard of with that kind of equipment. With that new camera, that just blows anything away. That 2600. Now, here are the two that with some a little more processing, and you can see together. And here you can see the detail, and once again in M82, and those reddish, a lot of that probably ionized hydrogen that's blowing out of the nucleus. And then here's the outer reaches here of M81. Here's a little, this is probably a dwarf companion of M81, and it's similar to some of the dwarf galaxies that surround our own Milky Way. Anyway, this is probably as far as I've ever been able to reach and doing any astro imaging up until now. Let's see, how do I I guess I'll have to hit this. Okay. Oh, wait a minute. Oh, now I'm getting this launch meeting thing here. Okay, how do I, oh, your screen, stop share. All right, here
There
we
you
go.
go. All right, thank you for sharing those.
Yeah, so anyway,
All right, our next meeting next month will be on, again, the third Monday, and that's April the 18th. So you can be looking forward to finding out what the meeting will be about sometime in the next couple of weeks when I get everything lined up. Anything else for this evening? All right, well, thank you all for attending. I'm going to stop the recording, and we'll post the recording sometime probably tomorrow. Thanks a lot.